today this title says solving quadratics by completing the square. We're really not going to be completely completing the square. We're not doing this technique. We're going to be solving, we're going to kind of cheat. We're just going to use a shortcut technique. We'll just call it, we're going to solve quadratics by taking square roots. All right, we're solving quadratics by taking square roots. All right, now completing the square, the process of completing the square is what you see on the board over there. It's a little bit complicated. You take half the coefficient of the middle term and you multiply it, you square it and add it to both sides, and then you use the square root property, which is what we're going to learn today, to finish the completion of the square process. So to complete the square, we have to use the square root property, and that's all we're going to use. I'm going to save completing the square for Algebra 2 for you guys. But this is one technique that you will learn in Algebra 2 that we're not going to learn in Algebra 1, completing the square. It is a very important concept. The skill is important. It's useful for lots of other things. And I may show it to you if time permits, but today we're going to be solving quadratics by taking square roots. All right. Now, we looked at a problem yesterday in class, if y'all will recall, and the problem was x squared equals 9. Y'all remember looking at that problem? And I asked you, can any of you see the solution to this equation? And you can, right? X equals 3 or x equals negative 3, because if we square 3, what do we get? 9. If we square negative 3, we get 9. Okay? So x squared equals 9. We solved it by factoring. We subtracted 9 equals 0, x plus 3, x minus 3, and we still get plus or minus 3. But the square root property tells us, guys, that if x squared is equal to b, then x is equal to plus or minus the square root of b. This is the square root property. You need to write this down. If x squared equals b, okay, if something squared equals a number, that's what we're dealing with here, right? X squared equals b, then x is equal to plus or minus whatever the square root of b is. Okay, so if we take what we did yesterday, x squared equals 9, and we just apply the square root property that tells us that x is equal to plus or minus the square root of 9, which is positive or negative 3. Now you can write your answer like that. That means plus or minus 3, positive or negative 3. Carson, or you could split it up and say the answer is 3 or negative 3, either one. All right? But that works no matter what number we're dealing with. Okay? So let's look at something else. Let's look at what we would get if we had something like x squared equals 7. Are the conditions of the square root property met?
No.
They aren't? The condition says if. Here's the conditions. If x squared equals a number. Do we have x squared equals a number here? Yes. All right. Then x equals plus or minus the square root of b. X equals plus or minus the square root of 7. Okay? Doesn't that make sense now? If you put the square root of 7 in here for x and you square it, what happens to the square root symbol? It goes away and you're left with 7. Right? Same thing if you put the negative square root of 7 in there and you square it, you get 7 when you're done. All right? So the conditions of the square root property are met there. All right? So what would we have here? Do what? X equals 5 or negative 5, right? Because the square root of property is met, which means that x equals plus or minus the square root of 25, and the square root of 25 is 5. All right, so this one has a nice rational answer. The last one we worked, the square root of 7 is an irrational number. Have irrational answers, right? The thing about this, if you have a rational answer, and I want to kind of show you this, if you have a rational answer, then that means the original equation, if we set it equal to 0, we could have factored that, right? Because x squared minus 25 is what kind of binomial? It's a difference of two squares. That's right. So we could factor it as x plus 5 times x minus 5 equals 0. And then we'd get that, right? X equals 5 or x equals negative 5. But x squared equals 7. If I set that equal to 0, can I factor that as a difference of two squares? Why not? 7's not a square, right? It's a difference of, I'd have to go to irrational roots there to do this. So the square root property works really nicely when you don't have perfect squares. If you have a perfect square, maybe it's just as easy to factor as it is to use the square root property. I'll let you decide that. All right, what about this? X squared equals 13.
It's
13 is not a perfect square, but does that mean we can't solve it? That's right. If we have something squared equals a number, we can invoke the square root property because the conditions of the square root property are met. If x squared equals any number, then x is equal to plus or minus the square root of that number. So the square root of 13 is just the square root of 13. There's nothing we can do with it. Fair enough?
Yes, is this all that?
It's pretty simple.
Yes.
X plus 3 squared equals 25. Any ideas on this one?
Make them x squared and 9.
No, can't do that.
Yeah.
Do what?
Would it not be 2 plus 3 squared?
2 plus 3 squared is 25, is it not? So we have a proposal here that x equals 2 is a solution, and it seems to be, right? But that's not the only solution, is it?
Are they negative 2 too?
No, negative 2 plus 3 is going to give us 1.
Negative 8.
Negative 8 would also work, right? But how do we get those algebraically? I do not want you to get into a habit of solving things by observation. It's good to use your observation to see what some solutions may be. Are the conditions of the square root property met here? Do we have something squared equals a number? We do, don't we? So I can invoke the square root property.
Do you have anyone else?
No, ma'am.
All right, thank you.
Such a loser.
Billy doesn't even remind you anymore.
It's not Billy's fault. All right.
Yeah.
If we have something squared equals a number, guys, we can invoke the square root property. If y'all don't pay attention, Brady. No, you're not. You'll be completely lost. And don't talk back either, knucklehead. X plus 3 squared equals 25. If we have something squared equals a number, then we can invoke the square root property. All right? X plus 3 equals plus or minus the square root of 25.
All you did was got root.
Yeah, so really kind of what we did here, guys, is we took the square root of both sides with an asterisk that I'm not going to go into. The plus or minus comes from somewhere that I'm not going to explain to you at this point. Okay? We're just going to use the property that tells us if we invoke the square root property, there has to be a plus or minus there. All right? Now, I'm not finished, am I? Why are we not finished?
You got to get root 3.
We got to get x by itself, so we need to subtract 3 from both sides and take the square root of 25, excuse me. So I'm going to have two solutions here. Can you see what the two solutions are going to be? Negative 3 plus 5 is positive 2, right? Negative 3 minus 5 is negative 8. So positive 2 or negative 8 are the solutions. So that's what one other variation of this could look like. Okay? Now this is, guys, this is where completing the square kind of comes from this. I'm going to show you one thing in just a second. But before we do that, I want to take this and go back. How would you solve this equation algebraically without taking square roots? What would you do to this? You think we could solve by factoring? We'd have to make it equal what? 0, right? So I could expand this right side, the left side, excuse me. That's x plus 3 times x plus 3, right? Could go ahead and subtract 25 and make it equal 0. Is everybody tracking with me? Now what's x plus 3 times x plus 3? X squared plus 6x plus 9, right? Plus 9 minus 25. What's 9 minus 25? Negative 16 equals 0, right? What are the factors of negative 16 that add up to be positive 6? Positive 8, negative 2. What are my two solutions? X equals negative 8, x equals 2. That's the same two solutions we got from taking square roots, right? I just want you to see, if you do the algebra correctly, whatever you do, you're going to get the correct answer. So you could solve it by factoring, set it equal to 0, use the zero product property. If it factors, it's nice. If it doesn't factor, then we have to use a different technique. Okay? But solving equations by taking square roots is it's pretty slick, actually. Don't write this one down, because I'm not going to ask you to do a whole lot of problems like this one and the previous one. X minus 5 squared equals 36. We have something squared equals a number, so we could invoke the square root property, which tells us that x minus 5 would be equal to plus or minus the square root of 36. We're going to add 5 to both sides. We're going to take the square root of 36. 5 plus 6 is 11. 5 minus 6 is negative 1.
Could you factor that one as well?
You absolutely could, because x squared, well, here's how I know it can factor, because the answers are nice, rational numbers. If your answers are rational numbers, what do we mean by rational numbers? Fractions or whole numbers, good fractions, good decimals, decimals that terminate or repeat. But these are rational answers, which tells us, actually, y'all watch this carefully. This is not in this lesson, but my factorization of this thing up here would be x minus 11 times x plus 1 equals 0. Now, where did I get those two factors from? From the answers, right? What would you get if you subtract 11 from both sides there? You get x minus 11 equals 0, right? If you add 1, you get x plus 1 equals 0. So there's my two factors can come from the roots. Now, let me go backwards here. If we squared the left side, we would get x minus 5 times x minus 5 is x squared minus 10x plus 25. Subtract the 36 and make it equal 0. What's 25 minus 36? Minus 11. What are the factors of negative 11 that add up to be positive 10? Excuse me, negative 10. X minus 11, x plus 1. What'd I tell you? So the two solutions are 11 or negative 1. And when we get a little bit deeper into this skill, I may ask you to solve something like this by factoring. So you'd have to expand it, make it equal 0, then factor it and set the factors equal to 0. You guys are doing great. All right, that's not your homework. I want to work a couple more of these before we're done here. Use square roots to solve this. Now, in this problem, Do we have the conditions of the square root property met?
No.
We don't, do we? Why?
Not x squared equals.
Because we don't have something squared equals a number. We have 2 times something squared equals a number. So what's got to go? The 2's got to go, right? 2's got to go, so if I can divide both sides by 2, what do I get?
8.
X squared equals 8. Now are the square root conditions of the square root property met? They are, right? So I can invoke the square root property because I have something squared equals a number. X will equal plus or minus the square root of 8. Is 8 a perfect square?
No.
Is the square root of 8 simplified?
No. Yes. No.
No, because it has a perfect square that will divide into it, right? It's 4 times 2. So the 4 gets to come out as what? 2. And the 2 is trapped inside. So that's the simplified version of the answer.
On a free response test, if we put x equals plus or minus square root of 8, will we get some credit or?
Minus 1 point for not simplifying. And the only reason that I dock any points there is just because it's so important for the ACT that you be able to simplify radicals. It's a huge ACT skill. You would never see plus or minus the square root of 8 as an answer on the ACT. It's not going to be there. Okay? So if you do the work correctly and then you look for that answer, it's going to kind of weird you out. Or maybe it'll remind you to simplify, but we're always going to simplify our radicals when they can be simplified. Okay, let's do one more. Let's do 3x squared. Actually, we're going to do 2 more. 3x squared plus 7 equals 19 works. Gives us a nice round answer, actually. Okay, now, the directions that I'm giving you is to solve by taking square roots. If I tell you to solve by taking square roots, that means I want you to get something squared equals a number. So how are we going to get the squared piece by itself?
You have to do divide 3.
Subtract 7 first, right? It's just like we're solving a 2-step equation. And that would give us 3x squared equals 12. Divide both sides by 3. Gray, when we do that, we have x squared equals 4. I know Brenna's bothering you, but
Yeah, I'm trying to scratch my back and she's looking.
Brenna, leave Gray alone. Just harassing him. All right, x squared equals 4.
X equals positive negative
X equals plus or minus the square root of 4. So let's just jump straight to that, right? We can do that. Now, the last example of the day is kind of an exception to the rule. All right, so let's look at 4x squared plus 7 equals, let's do negative 9. All right? The directions here say solve by taking square roots. So I need to get the squared part by itself, correct? I'm going to do that by first step. Subtract 7 from both sides. Just wait up. Don't steal my thunder here. 4x squared equals negative 16. Then what?
Divide by 4.
Divide both sides by 4, and that gives us x squared equals negative 4. We have something squared equals a number, right? But what?
It's negative.
And what does that mean? X equals plus or minus the square root of negative 4. Can we take the square root of negative 4 over the real numbers? No. And if you'll remember way back to the beginning of class, when we did our number defined what all the different types of numbers are, we said that the square roots of negative numbers are imaginary numbers. Okay? Imaginary numbers. So if you run across this scenario, here's what I want you to write. Okay? I want you to write no real solutions. I don't want you to write no solutions because this does have two imaginary solutions. It doesn't have any real solutions. And we're going to save imaginary solutions for Algebra 2.
Are you teaching algebra too?
No. I think Brady's mom teaches Algebra 2. Is that true, Brady?
Is that true, Brady? Brady, you do know.
Miss Clayton teaches Algebra 2. But this is a fluid situation around here.
What? No?
What I'm teaching this year, I may not be teaching next year.
I was already looking at me. Turn around now.
All right. Are there any questions? Y'all get this, right? So what's the gist? Somebody summarize the square root property for us. What do we do? What do we have to make sure we have for the square root property to be in play? We have to have something squared equals a number, right? Something squared equals a number. And then we can invoke the square root property. And the square root property will tell us that if x squared equals b, then, okay, condition, hypothesis, conclusion, x equals plus or minus the square root of b, whatever the square root of b is. It may be rational, it may be irrational, it may be imaginary, but the square root property always works. All right?